Hi everyone, in this video I am going to explain about the behavioral model of 328 decoder VHDL code. So behavioral model is very important where we are writing the process statement and then conditional statements in that to according to the behavior of the particular logic gate, logic function. So 328 decoder we know very well, it is having an enable pin. It is having an enable pin, a simple 328 decoder. It is not an IC. If it is IC, again it will be having different pins. So one enable pin we have along with the three inputs I0, I1, I2, 328 decoder, and total 8 outputs are there because n by 2 power n. The size is generally n by 2 power n. Here n is equal to 3. N equal to 3, then it gives you 3 by 8. The size is 3 by 2 power 3, 8 output lines. So y0, y1, y2, y3, y4, y5, y6, y7, y5, y6 and y7. This is what the 328 decoder VHD logic diagram. Okay. Now for this VHDL, for this the 328 decoder, we are going to write the behavioral style of VHDL code. Okay. So for any code, we know very well, first it should start with library IEEE, use IEEE dot std underscore logic underscore 1164 dot all 1164 dot all. And what are the inputs and outputs? As I said just now, entity decoder 328 is port of so enable pin in std logic enable pin is a single bit, semicolon. Next, inputs I in std logic underscore vector of 2 down to 0, and y is out std logic vector of 7 down to 0. Okay, these are the inputs and outputs of this particular 328 decoder and decoder 328. Generally, the input ports and output ports will not vary whatever may be the style of VHDL code, whether it is a data flow model. In the previous video, we have seen two styles of data flow model. One is directly on the Boolean expressions, another one is using conditional statements. Okay, those in that case also we have used the same entity portion maximum same. Here also for the behavioral model we are using, because the module is not changing. Whatever the module components we are having at the output and as well as input parameters, they are not changing. Inside the behavior we are writing in different ways to get the output. Okay, so now coming to the main important portion of this behavior architecture behavior of decoder 328 is architecture behavior 328 is begin we are writing the conditional statements in process of enable. What are the instances means which are changing with time, those are enable and I. So process, those instances should be written inside the process. So process enable I, process should begin if enable is equal to 1, if enable is equal to 1, then see in VHDL these brackets are not mandatory. If condition brackets are not mandatory. If you can directly write if space enable is equal to 1, then okay, that also program accepts. If enable equal to 1, now depends on the input combination 0 0 0 to 111, the corresponding output line is activated. Depends on the input combination, the corresponding line is activated. We know very well the operation of the 3-to-8 decoder. Okay, that all happens when enable is equal to 1. When enable is equal to 0, simply the output is, otherwise simply see here you can write also like when enable is equal to 0, when enable equal to 0, then y is assigned with all zeros. How many zeros? 8 zeros. Else now we have to go for the conditional statements. Conditional statements. The conditional statements we are writing here, it is case and when. Case and when. Case depends on which the output is varying, depends on I. Depends on I. So case I is when I triple zero, when triple zero implies y assigned with, what is the output for the y when it is, when I becomes triple zero? I means I2, I1, I0. So 000 means the corresponding equivalent by decimal number is 0. So y0 pin is activated and rest of all zeros. So it is 0 0 0 0 0 0 0 1 semicolon. This is the first line of the program. This is executed when enable is equal to 1. When enable equal to 1, that means else condition is activated. If enable equal to 0, the program will not go to the else statement. The program will be simply ended at this particular y is equal to all zeros. Hope you understand what is the meaning of this one. Okay. And similarly, for 0 0 1, for 0 0 1, y is equal to 4 zeros 0 0 1 0. 0 1 0 implies y is equal to 4 zeros 0 1 0 0. 0 1 1 means 3. Y is equal to, third line is activated, so y3 is activated, 1 and remaining are zeros. 1 0 0, y is equal to 1 0 0, y is equal to 0 0 0 1, 4 zeros. 1 0 1 implies y is equal to 0 0 1 0, 4 zeros, and 1 1 0 which is 6, so y is equal to 0 1 0 0 and 4 zeros, and 1 1 1, y is equal to, see here, for all ones we can write others. I told you already, other specifies it is the last statement. Other says that it is the last statement. When others, see, you have to write when also in front of this. I didn't write, otherwise I will write, see, when and the last one is when others, y is equal to this one. Okay, so other specifies it is the last line of the conditional statements. After that, you should not write any other conditional statement. Okay, it specifies it is the last one. So case is ended. So end case, and case above, if you go above again, if is there. So end if, again end process is there, end architecture. What is the name of the architecture? Behavior. Okay, this is the architecture of a behavioral model with the conditional statements. Okay, thank you.